All right, welcome back. So we're going to keep continuing with these trig identities and how we can use those to answer questions. So let's try this next one. So we want to use the trigonometric identities to transform the left side of the equation into the right side. So we have the tangent of alpha. So we're going to use a different angle. Sometimes they use other Greek letters. So tangent of alpha times the cosine of alpha equals the sine of alpha. Now, when all else fails, when you're talking about trig, one of the best tactics to kind of break a problem down is to change everything into sines and cosines. And if you do that, then usually you can start to see where things will cancel out and reduce down. So in this case, we already have a cosine and a sine here, so let's change this tangent into into sine over cosine. So again, you're always trying to reduce one side and make it look like the other. So since this side is pretty simple, we don't have to really do much to it. We'll just keep breaking down the left side. And we can see in this case, we're done. If we put the cosine over 1, we can cross cancel these cosines out. And lo and behold, sine of alpha equals the sine of alpha. So it checks. That one was a nice little warm-up, but let's try one a little bit tougher. So this next one, so we got sine over cosine plus cosine over sine is equal to the cosecant of alpha times the secant of, of theta times the secant of theta. So we switch back to thetas. But now, how do we want to break this down? Well, in this case, we have two fractions here with different denominators. So probably the first thing to get the ball rolling would be just to try to get those combined into a single fraction. And then maybe we can tackle more from there. So what would be our common denominator in this case? So we have cosine of theta and then the sine of theta. Well, if you don't have any clue of what your least common denominator is, you can always fall back on just multiplying the two denominators together. So in this case, I like to have sine first. So let's put sine of theta times the cosine of theta. So that will be our LCD. So now if we start to rewrite this a little bit, we know that our denominator is sine of theta times the cosine of theta, sine of theta times the cosine of theta. And so if we modify the bottom in this way, technically all we're really doing is multiplying top and bottom by the sine. That's what's missing from this fraction. So if we multiply sine times sine, remember, we can write that as sine squared of theta. So that should take care of the first fraction. But our second one, now what's missing is our cosine. So if we multiply the bottom by cosine, we have to multiply the top by cosine, and that should give us cosine squared of theta. And again, we want this to eventually equal cosecant of theta, secant of theta. All right, well, now that we have a common denominator in both cases, we can combine those two fractions into one single fraction. So that one single fraction should look like the sine squared of theta plus the cosine squared of theta all over the sine of theta, cosine of theta. Now, if you're already ahead of me a little bit and you already know the answer, that's good. But let's keep going through the process just to make sure that we have it down. So now we have this, which looks like a really big mess. But if you remember from the previous page, sine squared and cosine squared is a nice Pythagorean identity. And that is going to be equal to 1. So we can wipe out this whole thing can rewrite this as 1 over the sine of theta cosine of theta. So we have that. And so now the last thing we got to do is we can kind of start to see that if we put this as 1 over the sine of theta times the 1 over the cosine of theta, that's the same thing as up above, right? So, and now we can see that we do end up with our right-hand side. So that does equal that, and so we're done. All right, so that one was a little bit trickier because we had to remember some things from fraction land, but breaking all that down, we do get to what the other side is equal to. So we're going to stop the video here, and then we'll start looking at these next problems in the next video. See you soon.